Guten Tag, hallo und herzlich willkommen zu der ersten Ausgabe vom VF Talk 21 zum Thema Nachhaltigkeit. Mein Name ist Marcel Delavi, ich bin Partner und Geschäftsführer bei der Design Engineering Zürich. Wir sind einer von vielen aktiven Partnern in dem Mechatronik-Netzwerk Virtuelle Fabrik. Der VF Talk bis jetzt kennt ihr als physisches Erlebnis mit Live-Speeches, Podiumsgesprächen und der Möglichkeit, alle Partner von der virtuellen Fabrik live kennenzulernen, sich austauschen und das Dienstleistungsangebot so kennenzulernen und abzugleichen. Dieses Jahr sind wir online und präsentieren unseren beliebten Anlass somit auch einem breiteren Publikum. Wir freuen uns also sehr, euch da quasi virtuell zu begrüßen und wünschen euch einen spannenden Input mit einem spannenden Fachreferat und im Anschluss eine erfolgreiche Vernetzung auf unserer WonderMe-Plattform. Es sind insgesamt 6 Events rund ums Thema Nachhaltigkeit, ganz ein wichtiges Thema, sind geplant und heute starten wir die erste 3er-Serie vom Juni. Die Events finden jeweils an darauffolgenden Donnerstagen am 4 Uhr, so für eine Stunde statt. Im Juli, August machen wir dann Sommerpause und im September geht es weiter mit der zweiten Serie der VF Talks. Wir sind hier bei unserem VF-Partner ADI, Agentur für Digitales, im Studio in Zofingen. Und ich freue mich sehr, bei mir ist der Joël Busset von der Distron AG. Salut Joël.
Hallo Marcel.
Der Joël kommt aus unserem schönen Nachbarland Frankreich und weil ich mein Französisch doch eher in den Ferien einsetze, switchen wir jetzt aufs Englisch und nicht aufs Französisch. Joël, we've known each other for a few years now from the development of the Ultra Pro device. You are co-founder of Distro and CTO. And you're based in Zurich and originally a spin-off of the ETH Zurich, is that right?
Yes, that's correct. The technology was originally developed at ETH and we are an ETH spin-off. The company was founded 8 years ago. We're still based in Zurich, but now we have a subsidiary in France and one opening in Germany also.
Okay. And how do you feel about the topic of sustainability? I mean, the world has changed a lot in recent years. The issues surrounding climate change alone are enormous. What do you think about it?
It is a very important topic for us. We're happy to contribute and to be part of the solution. The industry is trying to lower its impact and on climate change, on global warming, but they need solutions to be able to continue fulfill the requirement of the economy, the society, and this is where we try to provide innovative solutions.
Okay, that's interesting. So we, Distro and Design Engineering Zurich, have had a very exciting and intensive development in the last years, and the device Ultra Pro has now been available on the market since September 2019, is that right?
Yes, correct.
And I think I will now give you the floor for your presentation. Okay, so curtain up.
Yes, so thank you for having me. So I prepared a presentation to show you what is the sustainability problem that we tackle in practice and what is the solution that we propose to help our customers lowering the environmental impact that they have. And last, I want to discuss shortly how Swiss local startup like us was able to change globally, have a global impact on how the industry is working. So what is the problem for the industry? This is typically what the industrial side of our customer looks like. There's thousands of kilometers of pipes, thousands of flanges, connection valves, and all of these elements may potentially leak. And the current solution nowadays, they would force you to go to each of these elements with a sensor and assess whether the pipe is healthy, if it's leaking, if there is a risk in the future. And it is simply impossible then with this kind of, with the current technology to do that. but it is absolutely necessary because accidents happen. This, for example, an incident that happened in California in 2015. And what we see here is a huge methane cloud. The methane is not visible with normal light, but this image is actually an infrared image specialized to detect methane. And during this period, for this incident, about 100,000 tons of methane were released. And there is not only this kind of huge incidents. What are the risks that we try to prevent? There is a safety risk. This is these major incidents, but also trying to avoid putting worker at risk, worker inside the plants. There is a reliability issue that is also called availability of the plant or uptime. And this is that, especially in the current context, it is very important for the industrialists to have the plant running all the time. It is important both to have the plant making money, and it is important to ensure that the economy continuously gets the necessary supply. So this can be in terms of electricity, it can be fuel. Another aspect is energy efficiency. So energy efficiency, this is mostly due to compressed air leaks. So compressed air is used as a medium to transmit energy inside the plants, and this is a pure waste of electricity. Last is the emission. So they could be of pollutant, which has a big impact on global warming itself, possibly, and also on the safety of the population, of the community nearby, but also directly greenhouse gases, such as CO2 or methane that we saw in the previous example. And all of these together, they make a huge sustainability problem for the infrastructure, for the environment, for the climate. So if we are back to our original problem, the plants and the fact that our customers are not able to inspect completely their installation, what would be needed is a device that from a distance is able to inspect, scan the entire plant, taking a photo with a wide angle and indicating to the operator where are each of the leaks in the plant. And this is exactly what we developed. So we developed an ultrasonic camera that is specialized for gas leak detection. And what it does is it scans the environment in front of it, and it shows in real time on the screen at the rear of the device the leaks that are being found. So now how it works. Leaks, because of the high flow of gas, they create sound, and typically they create ultrasound that human cannot hear, and this ultrasound propagates through the air to the acoustic camera, to the device. So I have one device here. So what you can see in the front of the device is this black holes there that are each microphone. So there is 124 microphones on this device, and this microphone, they record the sound coming from the leak, but not only are they able to tell you that there is in the environment the sound from a leak, so there is a leak, but they're able to localize the leak by the fact that we have 124 of them. So how does the pipeline look like? The camera detects the sound of the leak. Then we have an acoustic processing pipeline that will identify for each sound where it comes from. This is displayed then overlaid on a video image on the screen live on the camera so that the user can identify the leak. And once the user identifies the leak, then they can take a photo or record a video of that leak. And we have softwares for users to be able to label the photos that they took, arrange them into report, and share them with their collaborator until the leak is fixed. So this is how an inspection works in practice. The operator enters a room and scans the entire space, looking for the gas leaks that are in the environment. Then once a leak is found, you see the operator sees it already on the screen and will try to make sure that the leak is really present and make sure of the location of the leak. And this is what the user sees in real time. So you see here the indication that is on this element that is leaking, and the device also quantifies the leak in terms of how many liters per hour are escaping from this leak. And how does this make a difference in practice? It is fast. It is the fastest leak detection method, and it is able to detect all gases. So what it allows is for a customer to do a full plant inspection, to inspect all the elements of their plant, which was not possible with previous technologies. It is also safer to operate. Safer because you can find leaks from a distance up to 50 meters, which reduce both exposure of the user to the gas, which can be a dangerous gas or toxic gas, and reducing the work at height. You don't need anymore to build a scaffolding to access each element. Also, we have a version that is ATEX certified, so safe to be operated in explosive environments. It enables our users to do more reliable inspection, meaning that the inspection does not depend on the goodwill of the operator or its qualification. So with any trained operator of the device will find the same leaks, no matter how long they spend inspecting the plant. It also then altogether reduces the amount of non-detected leaks. And it is an efficient method to use because it enables you to assess in real time the severity of the leak in order to be able to prioritize repair and track the evolution of the leak. Is it getting larger? Is it getting dangerous? So who are our customers? It is in the oil and gas industry, mostly refineries, in the chemical industry in general, also including pharma, and in the power plants, so electricity generating plants. And these customers, they have in common that they are critical industry. They are both critical in terms of what they provide to the economy, and they are critical in the type of product that they manipulate, potentially dangerous, potentially explosive. And another example of the use of this device in a critical environment is at the end of last year, NASA sent one of the acoustic camera inside the International Space Station to detect air leaks from the air from the cabin to the vacuum outside. So a bit of history to show you maybe how we did it. So the technology of sound localization was originally developed at ETH, and we were supported at ETH by ETH for a few years. So strong technological background. And we transitioned from this technology to testing and specifying the gas leak detection device with the industry, so with Alstom, now GE. And this led us to the first version of the device, later on redesigned to even better fulfill the need of the industry and the use device that is developed to be used by industrialists in real life plants. And this transition from technology to industry was extremely important in the development of the company, and we kept in this direction with now introducing the device for ATEX environments, so for explosible environments. Another key point to understand in the development of a company like ours is that we don't have the financial means to cover the market the same way a big group would do. We don't have neither the distribution network, so we need to stay on top of the competition and always have the most innovative device. So we try to achieve that in the past. We developed the first real-time portable acoustic camera. Then we went through acoustically transparent acoustic cameras, developed then the world's first ultrasound camera, which is the first device we sold to the industry for this gas leak detection application. We developed then an autofocus algorithm, also first, then the first ATEX ultrasound camera, ATEX acoustic camera in general, and the first device now in outer space. Okay, and last topic I would want to discuss about is how we did this. So this is the one device where we were in 2017, the first product that we were able to sell to the industry for this application. And we went through a large redesign phase to develop the device that I showed you and that we have today. So making this transition is not an easy task for a small company like us. There is a lot of skills that are required. There is some algorithmic design of the algorithm. There is a high performance embedded system programming to be able to run these algorithms on the chip in the device. There is more generic application software programming. All of these, they are skills that we do have in-house and that we had already for the previous generation of device. But in addition to that, there is more design and mechanical engineering skills. There is some rapid prototyping, iterating that is needed, some electronic and later on sourcing and manufacturing. So it is important for us to find a partner or several partners that can come together and provide us the skills that we are not able to have all internally. So on this project for design and mechanical engineering, we work with you, Marcel, in Design Engineering Zurich. For rapid prototyping, we work with rapid manufacturing. For the electronic design, we worked with Lightvert and Art of Technology, both also in Zurich. So this is why I'm happy to be here today and show you a bit how you contributed to this project and to sustainability.
Very interesting. Thank you very much for this exciting presentation. And Joel, I can really feel your passion for your product, and that's really great. So I have still 2 or 3 questions about it, okay? What did people do before, before this very helpful measuring device existed?
Yes. So the common things to all the techniques that were used before is that you need to inspect every single vessel one by one. So the most used technique is just soapy water. So you can imagine you put soapy water on the pipe. If you see bubbles, it means there was a leak. So you can imagine how time-consuming this method can be if you would want to inspect the entire plant. Another typical method is to use sniffers. So it's the sniffer is a device that measures the concentration of the gas in the air, but it remains the same. You need to inspect every piece of the pipe that you think may be leaking.
Yeah. Okay. And what is the future of Distron? Where do you see your company in, 5 or 10 years?
So when we started in this application 5 years ago, nobody knew about acoustic cameras. Where we are now, and what we see is that this technology works so much better than the existing techniques with Eclipse that there's no doubt for us that in 5 years, this will be in the standard toolbox of any operator that works with compressed gas in general. The challenge then for Distron is to have our device in this toolbox and not the one of a competitor.
Okay, yeah. And do you have any other products planned?
So we have many projects in development. What you have to see is that our device detects ultrasound, not only gas leak. So there is many other things that we can detect with ultrasound, and or that are relevant for users to monitor the element in their plant. So we want to develop also in these other directions.
Okay. That was very exciting, and the time is already up. So here's a little gift for the great cooperation, and c'est un crémant de l'Alsace.
Thank you. Thank you very much, Marcel.
And thank you very much, and I wish you and your team all the best and much success, and that you fly much further than into space with it, okay?
Thank you. Thanks a lot.
So, great. I will switch back to Swiss German. Und und ihr, liebe Zuschauer, habt jetzt die Möglichkeit, mit dem Joel Busset noch live zu reden, und zwar auf unserer WonderMe-Plattform, wo wir uns treffen werden. Den Link dazu findet ihr auf der Website, wo ihr euch gerade befindet. Einfach draufklicken, euch einloggen und schon geht's los. Wir sehen uns dort. Und geht dort weiter im Austausch rund ums Thema Nachhaltigkeit und der Ultrasound-Kamera. Und Partner von der virtuellen Fabrik sind natürlich auch dort. Wie gesagt, der Joel ist dort, und moderiert wird das Ganze vom Alain Stäbler. Er ist ebenfalls VF-Partner und CEO von der Rapid Manufacturing AG. Also bis gerade, wir freuen uns auf den Austausch mit euch. Bye bye, and Joel, see you again in space, okay? Or virtually, or whatever, I don't know.